You know that feeling when you walk into a server room? It's a very specific vibe. That constant low-frequency hum of the fans,
Yeah.
the blinking green and amber lights.
Mhm.
For a long time, that room was the center of the universe for IT, the sanctuary.
Oh.
But lately, for a lot of people we talk to, that room feels less like a sanctuary and, well, more like a boat anchor.
An expensive, hot, and very loud anchor that you have to keep air-conditioned 24/7.
Exactly. You've got this aging hardware, right? The fans are wheezing, and then your boss comes in asking for AI-ready application.
Of course.
They want massive scale, instant global reach, and you're just looking at a rack that is like barely handling the internal email server without overheating.
It's the classic infrastructure burden. You want to build the future, but you're just stuck patching the past.
And that is the tension the source material for this deep dive really addresses head on. We're looking at a stack of technical training modules from Microsoft on Azure App Service.
Right. And the core argument here isn't just move to the cloud for the sake of it. It's about shifting your whole mental model from, maintaining servers to just shipping code.
Okay, so the promise is that Azure App Service acts as the hero that takes that hardware nightmare, the patching, the racking, the stacking, and just makes it Microsoft's problem.
That's the idea.
But I want to be careful here. We're not just reading the brochure.
Hmm.
We need to see if it actually delivers on that. Does it work that way in practice?
That's the goal today. We're going to strip away the marketing and look at the actual mechanics, the scaling, the deployment slots, which are, I think, the killer feature here,
Like that.
and the security model. We need to understand how it changes the job.
So let's start with what I think is a bit of an identity crisis. I think a lot of people hear Microsoft Azure App Service, and their brain immediately auto-completes to Windows Server hosting for .NET apps.
Oh, for sure. It's a hangover from 10, maybe 15 years ago. But if you look at the documentation today, the very first thing that jumps out is the term polyglot.
Polyglot. So it speaks many languages.
Exactly. It creates a standardized operational layer no matter what the developers are writing in. The source explicitly lists support for Java, Node.js, Python, PHP, Ruby, and of course, ASP.NET.
And the kicker, which I saw in the configuration screenshots in the source material, it runs on both Windows and Linux.
Yes, and that's what usually surprises people. You can literally select a Linux environment running, say, Python 3.9 or Java 17. You are not forced into a Windows environment if that's not your native habitat.
And that matters because usually in an on-prem world, the Linux team and the Windows team are like in totally different silos.
Different tools, different monitoring, different headaches.
Yeah.
App service abstracts that underlying OS away. You're managing the service, not the kernel.
So effectively, I don't care about OS patching anymore. I don't have to worry about some security vulnerability in the Linux kernel.
You shouldn't. That's the whole PaaS platform as a service value proposition. You're not SSHing into a box to run sudo apt-get update on a Friday night. Microsoft's global data center infrastructure handles all that. The physical hardware, the power, the cooling, the OS patching. You just worry about your application files and the config.
Which sounds great, but let's get practical. I'm in the Azure portal. I'm creating a new app. The sources walk through this hello world moment, and it seems simple, but there are some forks in the road right at the start.
There are. First, you're claiming your namespace. You get that default URL, something.azurewebsites.net. It has to be globally unique.
Right, because it's a public DNS record.
Mm.
Fine for testing, but we'll talk about custom domains later. No one wants my-coolapp-test-v2.azurewebsites.net on a business card.
Agreed. But the real structural decision is the runtime stack and the region. You tell Azure, I need a container for Python, and then you pick where it lives.
And this is where the app service plan comes in, which I know trips people up.
It does. Let's unpack that. Because you don't really pay for the app, technically. You pay for the plan.
It's the engine under the hood.
Think of it as the rental agreement for the compute resources. You're renting a set amount of CPU and RAM. You can put one app on that plan, or you can cram 10 apps onto that same plan to save money.
As long as they don't eat up all the resources.
Mhm.
So if I have a really beefy plan, I can run my website, my blog, and my API all on the same bill.
Exactly. But if one of them goes viral and eats 100% of the CPU,
They all slow down. It's a shared apartment.
it is.
Got it.
Mm.
Now, once the app is spun up, the docs highlight this menu called configuration. And this is where the it just works promise gets tested.
Yeah.
There are toggles here that can really mess you up. The first one that caught my eye was Always on.
Always on is critical. It's almost misleading that it's a toggle and not just a default for production.
Explain that. Why wouldn't I want my server on all the time?
Well, in a cloud world, resources cost money, and Microsoft is trying to be efficient. So by default, on lower tiers, if no one visits your site for, say, 20 minutes, Azure unloads it from memory.
Puts the app to sleep?
Essentially, yeah.
Yeah.
To save those cycles for someone else.
Which saves energy, saves money. I get the logic.
Sure, but imagine you're the next user who visits after that 20-minute break. You click the link, and now nothing. Or rather, it just spins and spins. You're waiting for a cold start,
That first click takes like 10 seconds.
which feels like an eternity. People assume the site is broken, but more importantly, and the source material really stresses this, if you have background tasks, like a web job or a CR on expression.
Like a nightly report.
Exactly. Those timers just stop if the app unloads.
So my nightly backup doesn't happen because nobody visited the website at 3 a.m. to keep it awake.
Precisely. If you're running anything production grade, you must check the always on box. It keeps the process pinned in memory.
Okay. Another setting mentioned is session affinity, which I know is sticky sessions. The training material frames it as a reliability feature, but isn't that kind of an anti-pattern in modern app design?
You're hitting on a really interesting debate. In a perfect modern 12-factor app world, yes, your application should be stateless. It shouldn't matter which server processes your request.
But we don't live in a perfect world. We live in a world of legacy code.
Exactly. A lot of older apps store the user's shopping cart or their login state right in the web server's RAM. If Azure scales you out to 3 servers, and my next click hits server B instead of server A,
My shopping cart vanishes. Disaster.
so Session Affinity drops a cookie on the user's browser that basically tells the load balancer, hey, keep sending this person to server A. It's a lifeline for legacy apps.
Okay, and the last toggle in that section was HTTPS only.
Which is the force security button. In 2026, there's zero reason to have this disabled. Just turn it on.
Let's move to what I think is the crown jewel of this entire service.
Yeah.
If you take nothing else away from this deep dive, it has to be deployment slots.
It is the feature that changes how you sleep at night. It absolutely changes your relationship with releasing code.
So break down the concept. How does it work?
Okay. Normally, when you deploy code, think back to the old FTP days, you're overwriting the live files. There's a moment of instability, maybe the site throws errors, or maybe you deploy and it just breaks.
And then you're debugging in production while your boss is standing behind your chair.
The worst feeling. So deployment slots solve this by creating a parallel universe. You have your production slot, which is live, and then you spin up a staging slot. It's a fully functional clone.
But it has a different URL, like myapp-staging.azurewebsites.net.
Correct. It's secret. So you deploy your new version to staging, you run all your tests, you click around. The public is still seeing the old stable version on production.
And then the swap.
The swap. You tell Azure, switch them. And this is where the magic is. The load balancer instantly redirects all new traffic. The staging slot becomes production, and production becomes staging.
The documentation claims this is zero downtime. But how is that actually possible? Connections have to drop, don't they?
You'd think so, but they don't, because the staging slot is already warm. It's booted up. Always on is running. The heavy lifting is done. Azure just drains the old connections and points new requests to the new one. The user never sees a glitch.
That's impressive. But my favorite part is the panic button aspect of it.
The rollback.
Yeah. I verified everything in staging. I swap. And suddenly I realized there's a bug that only happens with real customer data.
An edge case you missed. Happens all the time.
So with slots, I just swap again.
You just swap back. Your old production version is sitting safely in the other slot, untouched. You reverse the swap and you're back to the last known good state in seconds.
That sounds incredible, but there's a trap here, isn't there? The notes warn about sticky details.
Yes. This is the one place where administrators can get burned. When you swap, the code moves. But you can configure certain settings to not move, to stick to the slot.
Why would I want that? Shouldn't everything move with the app?
Well, think about your database connection string. You have a production database and a test database, right?
Right.
You do not want your staging code connecting to the production database while you're testing.
Okay, that makes perfect sense.
But when you swap that code into production, you want it to drop the test database connection and pick up the production one. You want that connection string to be sticky to the production slot.
Oh, I see. If you mess that up, you could deploy to prod and have your live customers writing data to your test database.
Or worse, you could wipe your test database and realize you just deleted production data. Configuring which settings are sticky is probably the most important part of setting this up.
Duly noted. Okay, let's talk about getting the code there in the first place. We're moving away from the right-click publish days.
Thank goodness. The module focuses heavily on CI/CD continuous integration and deployment. It integrates with GitHub, Azure DevOps, Bitbucket.
It mentions auto-synchronization.
It's a set it and forget it model. You link your app service to a specific branch in your GitHub repo. As soon as you merge code into that branch, Azure sees it, pulls the code, builds it, and deploys it to your slot.
It removes the human error. You don't have a developer forgetting to upload the right config file.
Exactly. Although I have to laugh, the source material lists manual deployment options, and it actually includes OneDrive and Dropbox.
I saw that. You could deploy an enterprise application by dragging a file into a Dropbox folder.
Technically, yes. Azure will watch a specific folder in your Dropbox and sync it.
That feels so wrong. It feels like 2010.
It's great for a prototype or, maybe a student project. But please, if you are listening to this and you run a bank, do not deploy your application via Dropbox.
Advice to live by. Let's pivot to security. Authentication. Now, I've written OS code before. It is miserable. Handling oath tokens, refreshing them, it's the easiest way to introduce a vulnerability.
And developers hate doing it. It's plumbing. It's not business value. You don't make money because your login screen works.
So how does app service handle this? The source calls it the easy button.
It basically acts as a sidecar. The authentication module runs outside of your application code. It sits in front of your app on the network layer.
So the request hits the auth module before it even touches my Python code.
Precisely. You turn it on, configure it to use Microsoft Entra ID or Google or Facebook, and if a user isn't logged in, the module just blocks them. Your code never even executes.
Yeah, I don't have to write a check if logged in function at the top of every single page.
Nope. You can set it to authenticated requests only. The module handles the redirect, the token handshake, validates the signature, all of it.
So wait, if my code doesn't do the login, how does it know who is logged in? I need to show the user their name or load their profile.
The auth module injects that info into the HTTP request headers. You just look for a specific header, like XMS client principal. The username and ID are right there, guaranteed valid by Azure.
That is slick. It completely decouples security logic from business logic.
It's a huge time saver. And it's arguably more secure because Microsoft's security team is updating that module constantly.
Okay, moving on to branding. The Azure Websites.net URL. If I want www.condaso.com, I need a custom domain. The source details two ways, a records and CNAME records. Is there a preferred path?
There is. A CNAME is generally better, and a record points your domain to a specific IP address.
Like 192.168, whatever.
Right. A CNAME maps your domain to another domain name. So condaso.com maps to condaso.azurewebsites.net.
Okay, and why is that better?
Because in the cloud, IP addresses are slippery. They can change. If you change your pricing tier, your IP might change.
And if I use an A record pointing to the old IP, my site goes down until I update my DNS.
Exactly. But if you use a CNAA, you're mapping to the name, which Azure automatically keeps pointed to the correct current IP. It's just much more resilient.
Makes sense. Okay, let's wrap up with operations. When things break, because they always do, we need backups, and we need eyes on the problem.
So backups are interesting here. If you're on the standard or premium tier, Azure can back up your app content, your config, and this is key, your connected database.
It grabs the SQL data, too.
Up to a certain size, yes. It bundles everything into a zip file and dumps it into a storage account. It's a snapshot of the entire state of the app.
That's a great safety net, but I'd argue monitoring is even more important. You want to know you're in trouble before you need the backup. This brings us to application insights.
The eyes and ears. This isn't just reading server logs. Application Insights is a full APM application performance management tool. It installs right into your runtime.
So it sees what the code is actually doing.
It sees everything. If your page takes 3 seconds to load, App Insights can tell you, okay, 0.1 seconds was the server, but 2.9 seconds was spent waiting for the database.
That dependency tracking is a lifesaver. It ends the blame game.
It's not my code, it's the network. Now you have data to prove it. It also tracks exceptions, browser errors, even where users are clicking.
It turns the server is slow into the server is slow because this specific SQL query on the checkout page is timing out.
Actionable intelligence, that's the difference. You move from guessing to fixing.
So we've gone from the freezing server room to a polyglot platform, used deployment slots for zero downtime swaps, automated the CI/CD pipeline, and set up deep monitoring.
It's a comprehensive suite of tools. It really is.
Thinking about all this,
Hmm.
and thinking about the listener who's maybe still babysitting those on-prem servers, what's the real takeaway? Is it just convenience?
I think it's about agility. The tools we talked about, slots, auto-scaling, pipelines, they let you move fast without breaking things. The old way forced you to be slow because deployment was so dangerous. This model creates a safety net that encourages speed.
And that leads me to a thought I've been chewing on. We call this platform as a service.
Hmm.
But when the platform handles the OS, the patching, the scaling, the authentication,
The line starts to blur, doesn't
it
it?
really does. At what point does the server just disappear entirely from your mental model? We talk about serverless as this other thing like Azure Functions. But
Right.
honestly, if I'm using app service right, I'm not managing a server anymore. I'm just a creator of logic. I'm just shipping code.
And that's the ultimate promise of the cloud, isn't it? To
Mm.
make the infrastructure invisible so the innovation can be visible.
A great goal to aim for. Something to think about next time you're staring at a progress bar. Thanks for diving in with us.
Always a pleasure.